Today I'm going to show you how to use Green's theorem to make this line integral over this curve really simple. First I'm going to write out what Green's theorem actually is, the statement of Green's theorem. So Green's theorem relates the line integral over a curve C, which in this problem is this curve that's going around the square. Line integral, let me do that again, of the form of a function of x and y like this, dx plus another function of x and y, dy, and it's gonna relate, I'm kind of running out of space, let me zoom out. It's gonna relate that to a 2D integral over the area enclosed by the curve, which we'll just call R here, over R. And it's related to this line integral in that 2D integral is over the partial derivative of q with respect to x minus the partial derivative of p with respect to y times the normal area element dx dy. Let's see how Green's theorem makes this line integral problem quite simple. So first let's identify what our p and q is. So p goes with dx, so in our case p is just a function of y, but I'll just still write it like this to make it clear, and it's going to be minus y, and I guess we could do a different color here, and our q is just going to be a function of x. And that's just going to be x. Okay. So in order to use Green's theorem, we have to find the partial derivatives of these two functions, which shouldn't be too hard. Partial derivative of, that's a really bad sign, partial derivative of p with respect to y is clearly just minus 1. And the partial derivative of q with respect to x is just 1. Okay, now let's use Green's theorem to relate this to a 2D integral. So let's write that out. Following the theorem, so we've got the 2D integral over R of dq by dx, which is just 1, minus dp dx, which is minus 1, dx dy. Okay, so this is clearly just 2, and it's just a constant, so we can take that out the front of the integral. Okay, and then we can see that this is just 2 times the 2D integral, or actually hold up, let's just write like this, integral over R dA, which is nothing but the area of this square. So the actual answer is nothing but 2 multiplied the area by the area of the square, which is just the square of side length 2, so the area is just 4. And that means that our line integral is just equal to 8. Let me write that here, equal 8. Okay, so that's how Green's theorem can make a line integral like this, really trivial. Thanks.